Discrete Math students, this is Miss Hamilton. Today we're going to review some of the things that we learned in our weighted voting unit. So veto power and dictators, Banzoff and Shapley-Shubik power distributions. So make sure you're watching this video, taking some notes, and answering your day 4 Google form. All right, so our first example is just going to be focusing on what is veto power and what is a dictator. So veto power means that if that particular person does not vote yes, the rest of the group cannot pass the motion without them. So in this particular example, if we look at person 1, so if person 1, that's this person, says absolutely no way, I'm not going to vote yes, then person 2, person 3, and person 4 only have 13 votes, and that will not get us to our quota of 15. So that means person 1 has veto power. All right, let's do the same thing for person 2. So now, once we're at person 2, person 1 is back in the mix. So if person 2 says absolutely no way, not going to happen, then person 1, person 3, and person 4 would be voting together, and they have a total of 14 votes, which is still not meeting our quota. So person 2 also has veto power. All right, let's try person 3. So if person 3 says absolutely no way, not going to happen, I'm not voting on this, person 1, person 2, and person 4 are going to vote together, and they are going to have 17 votes, which is enough to meet our quota. So person 3 does not have veto power. So in this particular example, person 1 and person 2 are the only people that have veto power. So a dictator is slightly different. A dictator has to be able to pass a motion on their own. So in this example, that would mean that somebody has to have 15 votes to give already, at least 15 votes. So in this case, there is no dictator because nobody has equal to or more than that. All right, so if you've got any questions about veto power or dictator, please make sure you put those in the collaboration document so your classmates and I can help you. All right, so our second 2 examples are talking about our power distributions, which are just showing us that sometimes power doesn't necessarily mean like the amount of votes that you have, it's how those votes can be used. So in this particular voting distribution, we're going to calculate the Banzoff power distribution. So the first thing that we need to do is we need to list our winning coalitions. So winning coalitions are just groups of people who can vote together and pass the motion. So the first winning coalition is the Grand Coalition. Player 1, player 2, and player 3 can all vote together, and they will definitely have over 9 votes. They will have 11, 12, 13, 14. All right, then player 1 could vote with player 2. If they do, they have 11 votes. That would be enough to meet our quota. Player 1 could vote with player 3. If they vote together, they have 9 votes. That's enough to meet our quota. And then player 2 could vote with player 3. If they vote together, they only have 8 votes, so this is not a winning coalition. All right, so in this particular case, we only have 3 winning coalitions. So the next thing we want to do is we want to identify our critical players in each coalition. And a critical player is essentially somebody that if we got rid of them, the rest of the players couldn't pass a motion without them. So in this first group right here, if player 1 is kicked out, player 2 and player 3 cannot vote together and pass the motion. So player 1 is critical. If player 2 gets kicked out, player 1 and player 3 can pass the motion. So player 2 is not critical. If player 2 is not critical, player 3 can't be critical either because they have fewer first place votes. All right, in the 2-player coalitions, if either one of these people is kicked out, the other can't pass the motion by themselves because we don't have any dictators. So everybody is critical in these next 2. So then we go through and we list what's called our critical counts. So player 1's critical count is 3 because they're critical 3 times. Player 2's critical count is 1 because they're critical once, and player 3's critical count is 1 because they're critical once. So that gives me a total of 5 in my critical counts. So then our power distribution, we use this Greek letter beta, capital Greek letter beta. It's the number of times that that player was critical over the total critical count. So 3/5 for player 1, 1/5 for player 2, and 1/5 for player 3. So this is our power distribution. This is showing us that player 1 has more power than player 2 and 3, but player 2 and 3 have equal power even though they don't have the same number of votes. So player 2 feels like they have a lot of votes. They have 5, but really they only have as much power as the person who has 3 votes as well. All right. Last example, let's look at the same voting distribution, weighted voting system, but with Shapley-Shubik. So Shapley-Shubik, instead of looking at winning coalitions, we're looking at sequential coalitions. So essentially, how many ways can I order player 1, player 2, player 3? So player 1, player 2, player 3, and then we can do player 1, player 3, player 2. And then we could do player 2, player 1, player 3. I hope you're kind of noticing my organization system. This will help you make sure you list all your options. And then we've got player 3, player 1, player 2, and player 3, player 2, player 1. So there's 6 sequential coalitions in a 3-person voting system, and we know that because for each of these spaces I have 3 people that I could assign, then 2 people, then 1 people. So that's a total of 6. Right, so in our sequential coalitions, we're looking for pivotal players, slightly different than critical players. For pivotal players, you're starting on the left-hand side. So I'm starting with person 1, and I say person 1 has 6 votes. So the motion can't pass with just person 1. Now let's add in person 2. So person 1 and person 2, if they vote together, they will have enough votes to pass the motion. So person 2 is our pivotal player. I do the same thing in the next one. Person 2 can't pass the motion by themselves, but then when we add person 1, we're good. Person 3 can't by themselves. When we add in person 1, we're good. Person 1 can't, but then we add in person 3. Here's where we get interesting. So person 2 starts. If we add in person 3, they still can't pass the motion together. So this time, player 1 is pivotal. Same thing over here. So then we go through, just like we did with the critical counts, we figure out what everybody's pivotal count is. So player 1 is pivotal 4 times. Player 2 is pivotal once, and player 3 is pivotal once. So our total is 6. So our Shapley-Shubik power distribution for player 1, it's 4/6, or simplified to 2/3. For player 2, it's 1/6, and for player 3, it's 1/6. So we see this distribution is slightly different than the one that we did before. We got different numbers, but the power is the same, right? Like player 1 still has more power. Player 2 and 3 still have an equal amount of power. All right, so go to your collaboration document if you have any questions. Make sure you're trying that Google form to get some practice, and I hope everybody is doing well.